Okay, part two of the vertical and horizontal asymptotes. Continuing on here with example 2. Go ahead and try and find the vertical and horizontal asymptotes. Pause the video and resume it. And I'll go ahead and start here. The vertical is going to occur again wherever the x value in the denominator gives us a 0 in the denominator. So we cannot have that 0. So we will use, let me shift colors here real quick. So for the vertical, I know that 7x plus 5 cannot equal 0. So wherever it does equal 0, I am going to get an asymptote. So if I subtract 5 and then divide by 7, you know what? I'm going to change this one. It'll work out better. Why not do 7x plus 14? For education purposes, this is what we should do. So, all right, change that function there. Sorry about that. Hope I didn't screw you up. The vertical will be wherever the denominator is equal to 0. So 7x plus 14 equals 0. If I solve this one, this will come out to be, when I subtract 14 and divide by 7, x is going to be negative 2. So I'd like to demonstrate real quick that this is true. All right, we put the function, it should already be in here. There we go. So that's the original guy. I can graph it. Okay, it looks like negative 2 is where the asymptote. I'm going to show you the table, second table. And right here you can see that at x is negative 2, we get an error. It tells you it right like that. So x can't be negative 2, that's your vertical asymptote. For the horizontal, we look at the powers. Well, what I notice is the top has a higher degree than the bottom. So what does that mean? There are none. And if we look at our graph, oops, there doesn't appear to be any asymptotes going in the horizontal direction. We don't see any. Going on down to the bottom one here. Let's separate this. Let's see what we have down here. Okay, I think when I wrote this, I'm going to change this one here so that it works out a little bit cleaner for us for the purpose of doing this problem. So let's change that. Change this. Let's take and make that, oops, it didn't work. Let's change minus 3 to a plus 10. This will be better for what we're doing here. So again, feel free to pause and return. And we'll go back to red. So first off, the vertical. Verticals are going to occur once again wherever the denominator equals 0. So this is why I changed it. It'll work out nice. X squared plus 7x plus 10. If that's equal to 0, this factors. We have x plus 2, x plus 5. Right, multiply that out, you'll get right back to where you were. So I have asymptotes at x is equal, let's put it down here. X at negative 2 and at negative 5. Those are my vertical asymptotes. Once again, easy to verify that. We'll type this equation into y equals and we'll show. Okay, so I've got the equation entered in here. That's our original. We'll look at a graph. Okay, the table is probably more convincing, so we'll go to the table and we will see at -2, there's an error. There will also be an error at x equals -5. So those are definitely locations where the graph does not exist. So at x equals -2 and at x equals -5, there are vertical asymptotes. As for the, let's extend this here. As for the horizontal, you look at the power. Well, the top is equal this time to the bottom. So when they're equal, when the powers are equal, I take the lead coefficient from the top divided by the lead coefficient to the bottom. That's going to be my asymptote. So in this example, my lead coefficient for the top, let's get down here more. Okay. Lead coefficient for the numerator is 2. Lead coefficient for the denominator is 1. So y equals 2 divided by 1. Well, that's just y equals 2. So we should see if at x equals 2, we're going to see that the graph has an asymptote there. Go back to our calculator. The equation is already entered in. Okay, there it is. And kind of hard to see here, but this part of the graph right here, it's going to go on forever in the x direction, getting closer and closer and closer to x equals 2 without ever reaching it. And that's also going to happen over here on the left. Let me move over there to show you. Okay, this gets closer and closer and closer to 2 also. So the table is a really neat way of seeing this. Okay, we see that those are the vertical asymptotes, but if I go up to positive infinity, these numbers are going to, the y values I'm looking at, are starting to get closer and closer and closer to the number 2. And you could sit here your whole life clicking the down button, and it's never going to get to 2. It gets closer and closer and closer without ever hitting it. I think you get the idea. One way I can speed this up, let's change the table set. Instead of going up by ones, let's change it so that we're going up here. I'll start at 60. So I'm at a nice interval of 10, and I'm going to go up by 10s. This will allow us to skip every 10. So 60, 70, 80, and so on. You can see now we're already up to 200, and we're still at 1.95, and that's going to go on forever. Now the negative direction, let's start the table back at 0. So we can see at 0, now we're going to go up to negative infinity. Well, once again, we're going to start from the top this time, getting lower and lower and lower and lower, closer and closer and closer to the number 2 without ever reaching it. Okay, so as I go left, the values decrease from the top. I see a graph shaped like this. As I go to the right, get back to 0 once again. As I go to the right and I let x get bigger, the y's are getting closer to 2, but this time they're approaching from the bottom. So the graph goes like this as I go to the right. So that's why I see this that way and this that way. Okay. So anyways, that demonstrates that the vertical and horizontal asymptotes are as the rule back here states that they should be. I gave you an example of each one. All right. The next thing we'll do with this is we'll talk about the domain. Kind of a little confusing at times here. So here we'll consider, let's say the function, I'll borrow one from the book here, f of x is equal to, let's say 3x cubed plus 7x squared plus 2, and that's going to be divided by negative 4x cubed plus 5. Well, first, the domain is going to be non-existent. The x values are going to be non-existent at the place where this denominator is equal to 0. So I go over to the side and I say, well, where does negative 4x cubed plus 5 equal 0? So I have x cubed is equal to negative 5 divided by negative 4, which is 5/4. And we're going to cube root that. So we have the cube root of 5/4, which is some decimal. I don't know the exact value of that. Now this value of x produces a 0 in the denominator, which means that is definitely not a part of the domain. Definitely is not a part of the domain. Now, because this number, I didn't mean to write there, because that is not a factor of the top. If I were to factor the top, I don't get this. It's not like I can cancel that out. Because this is not a 0 or a factor of the top, then this is actually also an asymptote. And if you plug this in and graph it, you'll see that. But once again, because it's not a factor of the top, not a factor of the numerator, this in fact is an asymptote. Now let's point out here that this is a vertical asymptote. Oops, didn't mean to do that. Now as for the horizontal, one thing we notice is the top and the bottom, the numerator and denominator, have the same highest power. When that happens, y equals this number, 3 over negative 4, or we call that negative 3/4. That's going to be our horizontal asymptote. But our domain, to make it clear, our domain is going to be basically all zeros except for the ones that produce the zeros in the denominator. All x values except for the ones that give us 0 in the denominator. So all reals that are not equal to the cube root of 5/4. Other than that, we have no restriction on what the x values can be. They can be anything other than that value. Okay, real quick here in the last couple of minutes, let's consider another one here. Also from the book. Here's the function. Now what I want to point out here is that this function actually factors in numerator and denominator. The numerator will become x plus 2 times x minus 1, and the denominator will become x minus 3, x plus 2. Well, I notice that both numerator and denominator have an x plus 2, so those cancel. However, when I look at the entire denominator, things that make this 0 are not part of the domain. So my domain is going to equal all real numbers that are not equal to 3 or negative 2. Suppose I should have wrote the negative 2 first because it's smaller. But that's my domain. As for the asymptotes, though, I do not have asymptotes at both of these values because there is a common factor here. This one does not produce an asymptote. This one does. So my asymptote, the vertical one, is going to be located at x equals 3. Now, a quick look at the graph of this function. There's the function. There's the graph. Does demonstrate an asymptote at x equals 3. Now, the calculator doesn't show this, but there is a hole in the graph at negative 2. So where x is negative 2, there should be a circle there, but the calculator is not capable of showing us that. Now, real quick before I run out of time, the powers are the same here. So that tells me that the last horizontal asymptotes at